Our universe is a tapestry woven from intricate patterns and interactions, a grand cosmic dance orchestrated by forces we often take for granted. These forces, the fundamental forces of nature, govern everything around us, from the smallest atom to the largest galaxy. They are the invisible strings that bind reality together. There are four fundamental forces at play: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. Each force plays a crucial role, each a distinct voice in the symphony of existence. Understanding these forces is key to unlocking the universe's deepest secrets. It's about understanding the very fabric of reality itself. These forces are not merely abstract concepts, they shape our everyday experiences. Gravity keeps our feet planted on the ground. Electromagnetism powers our homes and allows us to see. The strong and weak nuclear forces work within the heart of atoms, influencing the very building blocks of matter. Their influence is pervasive and undeniable. Gravity, the force we experience most readily, is the architect of the cosmos. It's the invisible hand that draws objects together, dictating the motion of planets, stars, and galaxies across the vast expanse of space. Imagine tossing a ball into the air. Gravity pulls it back down, an everyday example of this force at work. On a larger scale, gravity holds the moon in orbit around Earth and Earth around the sun, a delicate balance of motion and attraction. This cosmic choreography isn't limited to our solar system. Gravity governs the interactions of galaxies, drawing them together in vast clusters and superclusters, painting the universe with streaks and swirls of cosmic light. The very structure of the universe, its intricate web of stars and galaxies, is a testament to gravity's pervasive influence. While gravity governs the large-scale structure of the universe, electromagnetism takes center stage on smaller scales, dictating the interactions between atoms and molecules. This force arises from electric charges, positive and negative, that attract and repel each other. Imagine rubbing a balloon on your hair. The static electricity that makes your hair stand on end is a result of the electromagnetic force. This seemingly simple force is responsible for a vast array of phenomena. It's the glue that holds atoms together, allowing for the formation of molecules, the building blocks of matter. It's also responsible for light, a wave of electromagnetic energy that illuminates our world and carries information across the cosmos. From the chemical bonds that hold our bodies together to the technology that powers our civilization, electromagnetism is woven into the very fabric of our existence. Section 4. The strong hand within. Unraveling the strong nuclear force. Venturing deeper into the heart of matter, we encounter the strong nuclear force, a force of incredible strength confined to the nucleus of an atom. This force binds protons and neutrons together, overcoming the immense electromagnetic repulsion between like-charged protons. Imagine trying to press two magnets of the same pole together. The strong force is what overcomes this repulsion within the nucleus, holding the atom together. Without the strong force, atoms as we know them would not exist. The universe would be a sea of scattered protons and neutrons, unable to form the complex structures that make up our world. This force, though confined to a tiny space, plays an outsized role in shaping the universe as we know it. Section 5. The subtle whisper of decay. Exploring the weak nuclear force. The final force, the weak nuclear force, is perhaps the most elusive, yet it plays a critical role in the universe's evolution. This force is responsible for radioactive decay, the process by which certain atoms transform into other elements over time. Imagine a single grain of sand slowly disappearing over billions of years. That's the timescale and subtlety of the weak force. Though seemingly insignificant on a human timescale, the weak force is essential for processes like nuclear fusion, the process that powers the sun and other stars. Without it, stars would not shine, and the universe would be a much darker and colder place. The weak force, though subtle, is a key player in the grand cosmic drama. Section 6. The grand design, a universe of forces pointing to a creator. As we delve into the intricate workings of these four fundamental forces, a profound question emerges. How did these forces come to be so precisely calibrated? The values of these forces, their strengths and ranges, are incredibly fine-tuned. Even the slightest deviation would render the universe sterile and lifeless. For example, if the strong force were just a tiny bit weaker, stars would not be able to fuse hydrogen and the universe would be devoid of light and warmth. This remarkable fine-tuning begs the question, is this a result of random chance, or does it point to something more, a guiding hand behind the scenes? While science can explain the mechanisms of these forces, it struggles to explain their precise values. This is where faith and reason intersect. The exquisite balance and interdependence of these forces suggest a universe not randomly assembled but carefully designed, a testament to a creator's hand at work.